Okay, this is 6B test, and this we were supposed to write a cubic function whose graph passes through all four of those points. Okay, there's more than one way to do this. The fastest way is to just write it in intercept form. So now what are my x-intercepts? Well, this one is x equals -4, so its factor is x plus 4. This one is x equals -1, so its factor is x plus 1. Okay? This one is x equals 3, so its factor is x equals -3. And this is not a 0. This is a y, sorry, my mistake, wrong spot, x and a y. So we know we have y equals a times, we don't know the leading coefficient here. We don't know that number. That's what we're going to have to find out. Y equals x plus 4. Let's change it to black. And then x plus 1. And then x minus 3. Okay? And then what I'm going to do is take the 2 and plug it in here, 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 and plug the -2 in for y right there. So that's what I'm going to do. -2 equals a times 2 plus 4, 2 plus 1, and 2 minus 3, and that's 6, 3, -1. So -2 equals -18a, and you get 1/9 for a. So a can now go in here, and you'll get your equation. So y equals 1/9 x plus 4, x plus 1, x minus 3. That's the easiest answer. Now some people insisted on multiplying it through, so some steps to do that. You would get y equals 1/9, and I'll get x squared plus 5x plus 4 times x minus 3, and then I can FOIL that, and I'll get y equals 1/9 x cubed plus 2x squared minus 11x minus 12, and then that changes it into y equals 1/9 x cubed plus 2/9 x squared minus 11/9 x, and then what is it? 12/9 is -4/3. So that also works. That would be a lot longer than this. You can stop right there at where the purple was. A lot of people did this if they did it as a matrix, or maybe they did a cubic regression. They might have done that and got that out as well. So those are all possibilities. Okay, question 22. It says use finite differences and a system of system equations to find a polynomial function that fits the data in the table. Okay, finite differences, remember? Your first order it looks like that goes plus 14, and then it goes plus 30, and then it goes plus 52, and then plus 80, and then plus 114. That's your first order. Okay? First order is linear. Okay, but it's only linear if it's constant. It's not a constant change. The change is changing. So we need to check the second order. So let's try that one in blue. Second order. Well, that looks like it's by 16, getting bigger. This one looks like by 22. This one looks like 32 bigger. And this one looks like 34. Sorry, not 32, 28. I need to erase this. And the last one looks like 34. Okay, so that if that was constant, it would be a quadratic. So this would be x squared of some kind. Okay, so we'll check the third order. I think you already know the answer there. Then the third order looks like plus 6, plus 6, plus 6. And that would give you a cubic. So it's going to be something of this power. Ax cubed plus bx squared plus cx plus d equals some number. That's f of x. Okay, that's what it's going to be. So we need to figure that out. So we're going to write a system of equations, and we're going to base it on each coordinate. So I'm going to do, the first coordinate is here. So for 1, 5, I'm going to make an equation. Okay? And so the a value I don't know, but I know that x cubed, so this is 1 cubed plus 1 squared for the b plus 1 to the first for c plus 1d, because there's a single d here. There's the number 1 right here. Okay, so I'm just I plugged 1 into each of these x's. Okay, and the output is 5. Okay, and so that, if you want that equation, that is really 1a plus 1b plus 1c plus 1d equals 5. And when you put the coordinate in 219, which is the second coordinate on here, this one there, up top in there, you're going to get 2 cubed, which is 8a. You're going to get 2 squared, which is 4b. And you're going to get 2c. You're going to get 1d equals 19. And when you put the coordinate 349 in, you know you're going to equal 49. And you're going to have to go 3 cubed. 3 times 3 times 3 is 27. A's. And then you go 3 squared is 9 b's. And 3 c's and 1 d. And when you can use any of these, but I'm going to use 4 here. 4, 101. Then 4 squared, 4 to the third is 4 times 4 times 4 is 64. And then 4 squared is 16. And then 1d equals 101. Okay? And on the next page, that will give you a matrix you can enter in. Remember, you can put it into a matrix. You go second, x to second on the calculator, x to the negative 1 key gives you a matrix. And when you're in there, you're going to go to edit, and you're going to set up a, what it looks like a 1, oh, it didn't go the way I wanted to. A 1, 2, 3, 4 by 1, 2, 3, 4, 5. You want a 4 by 5 matrix when you do the edit. So I'm going to scroll to the next screen, and that's going to look something like this. The matrix, when you enter it in, is going to be 1, 1, 1, 1. Now you won't see the dotted lines that I'm putting in. It would be a 5. Then it would be 8, 4, 2, 1, 19, and then 27, 9, 3, 1, 49, and I'm going to pause it. So there's the matrix, and on that matrix I'm going to have to RREF it. Remember how you do that? Second matrix, and then you're going to do math, and you scroll down till you see RREF. And when you do that, you'll get an output that looks like this.